In this video we'll be exploring the quadratic formula, the basic elements of it, what it is, how we derive it, and some of the ways in which we use it and why we do so. The formula itself is the solution to the following equation. If we have a quadratic equation, x squared plus bx plus c, and we've set it equal to 0, the quadratic formula itself is the solution to this problem. And it says that x can be equal to negative b plus or minus the square root of b squared minus 4 times a times c. And this is all divided by 2a. And there is one piece of the quadratic formula that we use quite often, and it is called the discriminant. So b squared minus 4ac is what we know as the discriminant. And we'll talk a little more about that coming up, but you can note already that if it is negative, that we have a big problem. The square root of a negative number is not possible, so when the discriminant is negative, it's going to mean that we have no solutions. And if it's equal to 0, you can see that we'll simply have negative b over 2a, and there'll be one solution. And if it is positive, then we'll have something that we add and subtract from negative b, so there'll be two solutions. And that's the basics of it. We'll practice that in a little bit. Now the deriving of it, it's good practice. It's a little bit challenging for some people to work through and not make some small mistakes, and hopefully I'll represent that well here as I try to solve it. But it's a really nice method called completing the square, and we'll show that in another video. But the process looks something like this. We take the constant c and we move it over to the other side, and then we factor out a from x squared and bx, and then we figure out the little piece we need to fill in for a perfect square here. And the perfect square in this case is going to be 1/2 of b over a quantity squared, and I'll also divide by a at this point, so we'll have x squared plus b over a times x plus b over 2a quantity squared. And we're not allowed to add things without subtracting them, so we'll also subtract it as well right here. This is the odd step that may be something you need to look at in completing the square. And therefore, I can take this extra piece and add it across, and then what I'm left with here is a perfect square. So I have x plus b over 2a quantity squared is equal to negative c over a plus b squared over 2a squared. And now we'll take a look at combining the two terms on the right side as an LCD. If we square 2a, we'll get 4a squared. So let's bring that in for the moment. So 4a I'll need over here, so minus 4ac, and you can begin to see this building now, and a b squared, and this is all over 4a squared, which is really the quantity 2a squared. And on the other side we still have x plus b over 2a squared, and now we'll apply the square root. And when we take the square root, we have to consider both positive and negative options. So we have x plus b over 2a is equal to plus or minus, and we'll take the square root of the top here, which is going to be the square root of, and it should be now looking pretty familiar, b squared minus 4ac, and the square root of 4a squared is going to be just 2a. It starts to make things look a lot easier to work with. And then finally we'll subtract b over 2a across, and we will have our finished form of negative b plus or minus the square root of b squared minus 4ac, whoops, back that up, b squared minus 4ac all over 2a. And that is the derivation for the formula itself. And now we turn to looking at how we use the quadratic formula. Its main purpose is finding the roots for equations that are, quadratic equations. So the quadratic equation in general, looking like this, ax squared plus bx plus c is equal to 0. This is the main purpose of the quadratic formula, to help us find the solutions for x. And the discriminant itself we'll take a look at, but the discriminant, when it's positive, as we noted earlier, gives us two solutions. When it is 0, gives us 1, and when it is negative, gives us none. And we'll take a look at that visually in a moment here. It can as well help us to find the x-coordinate of the vertex of a parabola. And in fact, that's what's left over when we ignore the discriminant. So here we go. For the discriminant, let's call it d, and then let's look at the number of possible solutions. So if the discriminant is negative, so it is less than 0, then we have no solutions. If the discriminant is equal to 0, then we have one solution. And if it is positive, then we have two solutions. And the reason for that is that there are a couple of ways a parabola might be. It might be above the axis. It might be tangent to the x-axis. And it might cross the x-axis twice. So these points right here represent the number of solutions. And you can see that we have 0, we have 1, and we have 2 as we go. The vertex itself of the parabola we can think of in terms of the symmetry we see when we have two solutions. That if I have a parabola crossing the axis, and there is one possible answer here, maybe call this x sub 2, and call this one x sub 1, that right in between them, in the middle of these two solutions, is where the vertex can be found. And this little piece here is the plus piece, and this little piece here is the negative piece. And when we look at the formula itself, negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a, we can see that this little piece here is the plus and the minus that we're looking at. And therefore, right in the middle, we can find the x-coordinate for the vertex, which is simply going to be at negative b over 2a. So that's how we can find the vertex, or rather the x-coordinate for the vertex, how we can decide the number of roots that we might have, and a visualization of why that is. And now we'll give 3 quick examples, one of each type where we have no solution, one solution, and one where we have two solutions. And I've created them so they're quite nice and simple. The mathematics is quite straightforward, but they are representative of what you can do with a more complex problem. And in further videos, we'll come back to more challenging examples. So the first one we'll use is, imagine trying to solve for 0 is equal to x squared minus 2x plus 2. So the first thing we can do is check with the discriminant, which we would call as negative b, which is b squared minus 4ac. And if we check, in this case, a is equal to 1, b is equal to negative 2, and c is equal to 2. And when we substitute in those values, we'll see that we end up with 4 minus 4 times 2, or 4 minus 8, negative 4. So the discriminant is less than 0, and therefore when we look at the formula, and again I'll remind us, negative b plus or minus the square root of b squared minus 4ac all over 2a, that this portion under the square root symbol would be negative, and therefore we would have no real solution for our problem. So this one we don't even need to plug in all the way, because we know we'll have square root of negative 4. Now if we take another example that's a little bit more successful, then we have, say, x squared minus 2x plus 1. Now when we check the discriminant, and in this case our coefficients are a equals 1, b equals negative 2, and c equals 1, then the discriminant is going to be b squared, which again is going to be 4, minus 4 times a times c, which is 4, and that's 0. And so we decided earlier that that means we'll have one solution. And when we substitute in, we can see that that's in fact the case. So we'll take negative b, which is negative 2, or 2, plus or minus the square root of b squared minus 4ac, which we all said was 0. And we're dividing by 2a, which is 2. So now we have 2 plus or minus 0 over 2, which is 2 over 2, or 1. So this would indicate that there's only one solution to our problem, and that is x equals 1. Now, the third example is going to be 0 equals x squared minus 2x minus 3. And in this case, we'll take a look at our discriminant again. And our discriminant is going to be b squared, so 4, minus 4 times a times c. So it's going to be 4 times negative 3, and that's going to be 4 plus 12, or 16. And so then we should have two solutions. And let's take a look at that. Again, a is equal to 1, b is equal to negative 2, c is equal to negative 3. So when we plug into the quadratic formula, we have negative b, which is negative 2, or 2, plus or minus the square root of, and we just already figured out what c is, which is 16. And this is all over 2a, or 2. So now we have 2 plus or minus the square root of 16, which is 4. So this is equal to 2 plus or minus 4 all over 2. And we have two possibilities, 2 plus 4, which is 6 over 2, or 3. And the other possibility, 2 minus 4, which is negative 2 over 2, or negative 1. And these are our two possible solutions for x.